So with that being said, let's get started. I'm going to do, we've done some practice with sequences and series in our previous lesson, and I just wanted to do a little bit more with sequences and series because theoretically it's a section where we really should be getting maximum marks. Also, they will always have some kind of problem-solving question in here that's probably out of 5 or 6 marks, and we can certainly have a look at some of those as well. Okay, so let's consider the first question. It asks us to consider the following number pattern, and it goes -8, -7, 0, and then 13. So at a quick glance, we can see that it does not appear to be arithmetic because there's no constant difference. It also doesn't appear to be geometric, especially because it's got a 0 in it. We know we can't divide by 0. So if it's not arithmetic and it's not geometric, it's probably going to be a quadratic pattern. So the first thing that they want us to do is write down the next term in the pattern. And then if we cast our eyes down to question 3.1.2, they ask us to show that the nth term of the pattern is 3n squared minus 8n minus 3. So now we know for sure that this is a quadratic number pattern. So how are we going to work out what the 5th term in the pattern is going to be? How would we work that out? Okay, so Shoshana says using our second differences. All right, so if I set it out like this, Shoshana, the first thing that I'd get is our first differences. So here, what's the first difference going to be? The first term of the first difference. What's the first term of the first difference going to be? Can anybody tell me? That's it. It's going to be +1. Absolutely. Okay, so remember you're saying term 2 minus term 1. And over here, it's going to be 7. And over here, it's going to be, that's it, 7 and then 13. Okay, and then that's going to be 6. And this is going to be 6. All right, so first I added 1, then I added 7, then I added 13. So what do I need to add on to 13? This 13 over here, in order to get my next term. That's it. Okay, so it would be 6 plus 13. So I would need to add together these two numbers over here. Okay, because it increases by 13 plus that 6. So it would be 19. So 13 plus 19 means that this next term is going to be equal to 32. That's it. Okay, good. All right, so writing down the next term in the pattern, we've got 32.
I think
everybody's happy. Okay. Is it Mary Lynn? Is that, have I pronounced your name correctly? You're welcome to unmute and speak.
No, Miss, sorry, I made a mistake.
It's okay. No stress. But anyway, if you do want to ask a question, you're more than welcome to raise your hands and ask. It's not a problem. Okay, now when they say show that the nth term of the pattern is this, the words show that mean what, Matrix?
While they're busy answering that, I was just wondering, would they get penalized if they answered 3.1.1 by using 3.1.2?
No, not necessarily, but you actually don't need the answer from 3.1.1 to do the answer for 3.1.2.
Oh, so
So
the fifth term, and you just calculated for the fifth term, because that's what they were asking.
yes, that's what they were asking in 3.1.1. Yes, but you don't need the value of the fifth term to answer question 3.1.2. So no, they wouldn't be penalized, but it's not necessary. I mean, we could answer question 3.1.2 without knowing that that fifth term was equal to 32. It wouldn't make any difference to our solution. And the reason for that is because there are rules that they use to answer this particular question.
So
what they're not allowed to do is they're not allowed to verify. So in other words, what they can't do is take an answer from like they can't use the -8, the -7, or the 0, and then sub that into the nth term and work out what the answer is. So they can't do this. So this is not allowed. Okay, so if they do this, so 3 times 1 squared minus 8 times 1 minus 3 equals -8. That's not allowed, because by doing that, you are verifying, you are not proving. So good question, Yolanda. Okay, so what you're doing here, this is called verifying. And the CAPS syllabus never ever allows for verifying. When you are asked to prove something, so in other words, if I say to you, prove to me your name is Yolanda, and you say to me, Lee, my name is Yolanda, I'm going to say to you, but you haven't proved it. Okay, how can you prove your name is Yolanda? You can bring me your birth certificate, or you can bring me your ID or your driver's license. That proves that you are Yolanda. It's got to be done a different way. You can't just say my name is Yolanda. That doesn't prove it. Does that make sense?
Yeah, definitely. Because I was thinking that 3.1.1, instead of like answering it like that, I could have gone and taken the equation of Tn equals to, and just substituted the fifth term there to get 32. But I see that
No.
that's not.
No, that's not, that's not allowed, unfortunately. So you won't see, but Mosey has direct messaged me, and what they were saying is 100% correct. So in other words, we've got rules for this. So we're going to take this and we're going to say 2a equals, so our rule is 2a equals 6, therefore a would be equal to 3. That is correct, Mosey. That's the quite right. That's it, Sean. So what Sean's put into the chat is perfect. Okay, so 2a is equal to the second difference. 3a plus b is equal to the first term of the first difference, and a plus b plus c is equal to that. So that's what the matrix would have to use in this particular situation. Or whoopsie daisy, sorry guys, I was trying to move that over, not get the other thing off the screen. Okay, so perfect. So then we would go over here. We would say, let's just go up a little bit. So now we would say 3a plus b is equal, oopsie, sorry, I didn't mean to have that there. 3a plus b is equal to 1. So b would be equal to -8. And then a plus b plus c would be equal to -8. So in this case, c would be equal to -3. Okay, so the nth term would be Tn equals 3n squared minus 8n minus 3. All right, so your 3 marks there would be more really for that line over there, that line over there, and that line over there. They're not obviously going to be on the answers because the answers are given. Okay, so sorry, I should have put a number there. That was question 3.1.2. Very important that things are actually numbered correctly. Something else, I haven't actually mentioned this in any of the other classes I've taught, but be careful of your numbering in finals as well. So in other words, if you decide you're going to answer question 4.1.2 before you answer question 4.1.1, but you don't label it as 4.1.2, they're not going to put in on, they're not going to put in numbers for you. If you don't put a number there, they're not going to assume that, you know, it was the answer for whatever particular question. You're just not going to get the marks. So yeah, be very, very careful about your numbering. Okay, just as a little hint or a little tip going forward. Okay, now question 3.1.3 asks us, between which two terms of the pattern will the first difference be 79? Show all working. Okay, so what does this mean? How are we going to figure this out? How will we work out between which two terms? Okay, so you create a formula using the first differences and make it equal to 79. Absolutely, because just like this is term 1 and that's term 2 and that's term 3 and this is term 4, in your first differences, this is term 1, this is term 2, this is term 3, and this is term 4. So your pattern of first differences are always going to be arithmetic. So what we could do here even is to use this. So Tn equals a plus n minus 1d for our first differences. So now we're looking specifically at this row over here with the purple arrow. Okay, so 79 would go over there. A would be equal to 1 plus n minus 1. So we would be solving for n because they said between which two terms. So they want to know the position. And our differences here, we know that our difference is 6. So 79 would be equal to 1 plus 6n minus 6. So leaving the 6n on this side, we would have 79 minus 1 plus 6. Let's just go down a little bit. And that would give us 78 plus 6, which would be 84. And when we divide 84 by 6, we'd end up with 14. Whoopsie daisy. Okay, so now between which two terms would it be the difference be 79? It would be, so therefore between which terms in the quadratic pattern? Okay, so term 1 of your first differences lies between term 1 and term 2 in the quadratic pattern. Term 2 in the first differences lies between term 2 and term 3 in the quadratic pattern. So this will be between your 14th and 15th terms, okay, of your quadratic pattern. Is everybody happy with that? Does that make sense? Cool. Okay, so Mosey's okay. How about the rest of you? Is that all right? Making sense to you? Yes. Okay. All right. So it was out of 4 marks. So subbing in, maybe, so between the 14th and the 15th would be 1 mark. That would be a mark over there. I'm just trying to think where they would have put the, maybe it's a simplification mark. Okay. All right. So Mary-Lynn, you've got your hand up again.
Miss, I wanted to ask, I saw in another past paper they used the method like they said Tn plus 1 minus n minus Tn, and then they substituted that Tn plus 1 in the equation. Are we able to use that one also?
I did a question last week in a different paper where you had to do it that way. I'm just trying to think now. Yes, I think it would be fine if you did something like this. I think this is what you, let me just get rid of this thing. what I think you could do, because they're talking about the difference between the terms, right? So maybe if you did something like this, it would be a little bit longer algebraically, but you know that your nth term is 3n squared minus 8n plus minus 3. So you could go 3 into n plus 1 squared minus 8 into n plus 1 minus 3 minus, come on, pen, don't give me hassles. And then let me just, sorry, that was on our thingy over here. Just give me 1 second. I'm just going to scooch over slightly. Minus, and then here it would be 3n squared minus 8n minus 3 is equal to 79. You could do that. Is that what you're referring to, Mary Lynn?
You can either type or just unmute because you're muted.
Because they were specifically saying here between which two terms of the pattern will the first difference be 79. So yeah, you could do it that way as well if you wanted to, how I've done it in green. Obviously, that's a bit more of a pain in the backside algebraically than this one. It's just easier to work with your arithmetic term. Okay, but you could do it that way if you wanted, Mary Lynn. Okay, all right, I'm going to continue. If anybody's got any questions, you're welcome to unmute and ask as well. Okay, so now we jump into an arithmetic sequence. It goes 20, 23, 26, 29, 101. Now they want us to calculate the number of terms in the sequence, and then they want us to calculate, sorry, I beg your pardon, if the odd numbers are removed from the sequence, calculate the sum of the remaining terms. So I know I kind of tend to take over and do everything myself. Would you guys like an opportunity to try this on your own, and then we can talk about it afterwards, instead of me telling you what to do? Should we do that? I give you a chance to answer these two questions now that our brains should be sufficiently warmed up. Is that cool? All right. Okay. So what I'm going to do here, just to make life easier for you guys, is I'm just going to write the formulae down at the bottom. Okay. So you've got Tn equals A plus n minus 1d, and you've got Sn equals n over 2 into 2a plus n minus 1. Okay, so there are your term and sum formulae for you. Okay, so you guys are going to try those two, and then we can share our answers and discuss further. And again, remember, you can share your answers either by direct message to Yolanda or I. Try not to share it to everybody because we don't want anyone becoming discouraged if they're not finished quite as fast as you. Thank you, Mulebo. I don't know if I did something wrong, Mulebo. I didn't get the same answer as you. I'm just going to go back and check my working. We'll just see what some of the others say as well. Oh, there we go. Okay. Yeah, that's the answer I got too, Mulebo. I was just also going back over my working to see if I didn't make a mistake. Good, Chad. Yes, lovely. Well done. Nice. Watobe, I hope I've pronounced your name correctly. Good, well done. You've also got the right answer there. Lovely. You can go on to the next question now. No, I got a different answer to you, Chad. And also, I'll just check my working again. Boycho, is that for 3.2.2? That's what I got. That's what I got, Boycho. I hope I'm saying that correctly. Shisana, I got the same answer for 3.2.1. For 3.2.2, I got a different answer. Layer 2. I got a different answer, layer 2, for question 3.2.2. Yeah, I got the same answer for 3.2.1. Katleho, I would got a slightly different answer to you, very close. Just check your dividing there, Katleho. Okay, Mahle, the answer that you're giving me through 3.2.1, that's actually what you've got to use for 3.2.2. Trish, I got the same answer for 3.2.1. For 3.2.2, you are correct, but you haven't answered the question. But you're right about the number of terms in that answer. Yes, Katleho, that's right. There we go. I got a different answer to you, Molebo, for 3.2.2. Mary Lynn, good, well done. That's correct for the first one. Good, that's nice. There's some lovely answers coming through here, guys. But the second question is obviously creating, yes, that's part of it, Mary Lynn, but it's not the entire answer. But that certainly is part of it. Mbali, that's right. Don't doubt yourself, Mbali. Good. Okay, so let's go and have a look at the first question. So most of you seem to be finished with that already. So this is how I did question 3.2.1. And if you guys disagree or got a different answer, then please let's by all means discuss it. All right, so in this case, they asked us to calculate the number of terms in the sequence. So it's not a series yet anyway, okay, because they're not adding the terms together. So we're not using the SN formula because this number 101 is not an SN, it's a TN. Okay, it's the nth term in the yes. So whoever's got the Samsung, SMA346E. Yes, that is the correct answer. That's exactly what I got. So this 101 is a TN. It is not an SN value. So because the sequence is arithmetic, we are going to use the arithmetic TN. Okay, so TN is equal to A plus N minus 1 D. So 101 is the nth term of the sequence. The first term is 20. And we are trying to calculate the number of terms in the pattern. And we see there's a difference of 3 between the terms. So now we've got 101 equals 20 plus 3n minus 3. And if we leave our 3n on this side and we move the 20 and the minus 3 over to the other side, I ended up with 84 on this side, and dividing both sides by 3, I got n was equal to 28. That's it. Okay. So Amatle, this is one of the things that we need to be so careful of. All right. So we've got to answer the question that they're asking us. So if we jump forward and we get a different answer and we didn't answer the question, that's horrible for us because we know what we're doing. We know how to answer these questions, but because we didn't read the question carefully, we're not giving them what they want. Okay, so Letu, that's not what I got, but I'm going to show you my answer now, and then we can compare. All right, so this was out of 4 marks. Very important when you use a formula in maths, whether it's paper 1 or paper 2, you've got to show that you subbed in. So it's a mark for subbing into the correct formula. I don't know why it's out of 4. I would have actually put that out of 2, but anyway, never mind. There we go. All right, there would be 28 terms. Okay, all right, Mosey, I didn't get that, but I'm going to show you how I did this particular question. So they are saying to us, if odd numbers are removed, calculate the sum of the remaining terms. So in other words, when you look at this pattern, it begins with an even number, and then the next number is odd. And then the next number is even, and then the next number is odd. And that makes sense to us because we're starting with an even number and our difference is odd. So when we have an even number plus an odd number, we get an odd answer. When we have an odd number and we add an odd number, we get an even answer. So that explains why it goes even, odd, even, odd, even, odd, so onwards. Does that make sense to everybody? Just before I continue. Do you also see how the pattern began? Yes, okay. Do you also see how the pattern began with an even number? I'm sorry, I'm just reading what Mark sent to me. Mark. Yes, I mean, Amatle, if you had started with this, you would have got the marks for that, and then they would have disregarded the next thing that you've done. So yes, absolutely. Okay, you would have got the marks for this. Okay, and then they probably would have regarded the rest of it as a run on. That's what they call it. Okay, all right, Samsung SMA36346E. That's not the answer I got, but I'm going to show you what I did now, and then we can compare. Okay, so Voloshin, you asked me to repeat. So what I'm saying is this: your difference is odd. It's 3. You're starting with an even number. Even number plus an odd number is an odd number, always. And if you have an odd number plus another odd number, you always get an even. So that's why your pattern is going even, odd, even, odd, even, odd, all the way down to 101. Okay. So if it starts with an even number and it ends with an odd number, it's safe to say that if there are 28 terms in the pattern, 14 of them are going to be even numbers and the other 14 are going to be odd. Does that make sense to everybody? For me, I got it. Yes, that's the answer I got for me. Yes. Okay, so if they want to know the sum of the remaining numbers, what I would do is to calculate the sum of remaining. You could look at it in two ways. All right. If you understand what I'm saying about the odd, even, odd thing, then it's simply going to be the sum of the positive terms. Or, does that make sense to everybody? It's simply the sum of the positive terms. Or the other way of looking at it is that the sum of the remaining numbers is going to be the total sum minus the sum of the odd numbers. Does that make sense? So the other way that you could look at it is, or the sum of the remaining numbers is going to be the total sum minus the sum of the odd numbers. Now, does that make sense to everybody before I embark on my solution? Okay, so I know one person said, ma'am, please repeat. I'm happy to do so. Okay, so your pattern goes even, odd, even, odd, even, odd, even, odd, even, odd, and it ends on an odd number. So there are 28 terms in your pattern. If you started with an even number and you ended with an odd number, then it's safe to say that there are the same number as even and odd numbers in this pattern. So 14 of them, because the number prior to this 101 would have been an even number, isn't it? It would have been 3 less than 101. It would have been 98. Okay, so there are going to be 14 even terms, and there are going to be 14 odd terms. Yes, you can, Boycho, that's not a problem. So probably the most, even though it's a little bit more work, probably the most common way of doing it would probably be this way over here. So in other words, what you are doing is that your total sum of numbers would be, there are 28 terms in total. Okay, so it would be 28 over 2, 2a plus n minus 1 times d, minus the sum of the odd numbers. Now remember we said that there are 14 numbers that are odd. What is the first odd number in this particular pattern? It is the number 23. The next odd number is 29. So the difference between the odd numbers is 6. So that's why over here, A is going to be 23 minus, plus 14 minus 1, and your difference would be 6. Does that make sense? So remember, your pattern is going 20, 23, 26, 29, 101. Okay, we want the sum of the remaining numbers if all the odd numbers are removed. So that is the sum of the positive terms, or the total sum minus the sum of the odd numbers in that sequence. So when you pop that into your calculator, all right, you end up with a total sum of 1694. The sum of the odd numbers comes to 868, and the difference between these two sums is 826. So that's the second method. The first method, where you just found the sum of all the positive terms, you know that there are 14 terms that are positive. So that would be 14 over 2. The first term is 20. 14 minus 1, n minus 1, and your difference between your even numbers is also going to be 6. So when we pop that into our calculators, we end up with, should be the same answer. And indeed it is. Okay, so yeah, there was a quick and easy way to do it in the blue, but perhaps the orange method makes a little bit more sense. Are we happy with that, Matrix? You've all gone very quiet. Are you okay? You are, okay.
And please take screenshots if you're not.
Yeah,
Okay.
please take screenshots if you want to.
Yes, please.
So where possible, I think it's always nice for us to try and think of more than one solution. I think it just helps us to understand things. Okay, Samsung is like your shame. Sorry. This was a little bit more of a difficult question.
Here is level 4 then, or level 3?
Ma'am.
It wouldn't be a level 4 question, a level 3 question, yes.
Ma'am.
Yeah, yes.
It's
yes.
me, Samsung.
Yes, hello, Samsung.
So ma'am, so the thing is that I started by dividing the n, the n that we got, the 28, right? I divided it by
Yes.
2 so that I could get the 14 for the odd and also the even, so that I can know how much they are.
Yes.
So after that, I put them to the sum formula. But the thing is that, ma'am, I didn't get the answers that you got.
Oh, okay. You know what I think? I think that maybe when you didn't get the same answers as me, when you were doing, so in other words, if you got the 14, then when you were considering only the positive numbers, did you say that 20 is your first positive number? So that's going to be your A value. And then over here, 26 is going to be the second term. So that means that your difference is 6.
Oh, I didn't.
Did you say 3?
I said 3.
That's it. Yeah, that would be common. That's just your mistake there. Okay.
Oh, thank you, ma'am.
Oh, it's a pleasure. It's a pleasure. It's a pleasure. Yeah, that's what I thought your mistake would have been. Okay, so yeah, so the difference between the even terms is 6. The difference between the odd terms is also 6, but the difference between the odd and the even numbers is 3. Okay, all right, cool. So at least that's cleared that up for you, and hopefully Samsung is a little bit happy going forward. Sorry, I'm calling you Samsung. Please do tell us what your name is, and then we can change it. All right. Okay, cool,
Yes,
guys. Okay, you can just put it in the chat to Yolanda, and then she'll change your name for you. In the blue writing, why did ma'am use 20 as the first term and not 23? Okay, because it's fine, JV. Let's just go back to this. That's because in the first method, we are only considering the sum of the positive terms. So that's why 20 is the first term of the pattern, but it's the first term of the positive terms. Okay, if I was doing the total sum minus the sum of the odd numbers, then the first number in the pattern, that's an odd number, would be 23. Does that make sense, Jamie? So here I'm doing the sum of the odd numbers. So the sum of the even numbers, beg your pardon. So the first even number is 20, and the difference between the even numbers is 6. Okay, no problem. All right, cool. So let's go back and go and have a look at the last couple of questions, which are on geometric sequences. All right, so now they tell us that the first and the second terms of a geometric sequence are 1,21 and 1,331 respectively. In 3.3.1, they want us to calculate the 12th term of the sequence. And then in 3.3.2, they want us to calculate the sum of the first 15 terms of the sequence. So again, instead of telling you guys what to do, I'm going to give you an opportunity to do this yourselves. Remember, for a geometric sequence, your term formula is AR to the n minus 1. Your sum formula is A into R to the n minus 1 over R minus 1. That's an R. Okay, I'm going to let you guys do those questions. And then again, you can either DM myself or Yolanda with solutions, and then we can compare our answers. Cool, off we go. Oh, wow, and Valente, you are speedy. Mary Lynn, my answer was very close, but just out by a little bit. Boycho, my answer for 331 was quite different. Oh, have I made a mistake? Because I see Mbali's got the same answer as you. Imbalently. Okay, maybe I'm going crazy. Hold on, let me just do the first one again, because I'm getting a different answer. Oh, and Seth's getting the same answer as well. Okay. Oh, oh no, I did get that. I'm getting the same thing now. Why are you guys getting different answers to me? And Shisana and Jude. Okay. You're all getting the same answer for the first one, unless I feel like I'm losing the plot here. So hang on a second. So I think I know what I did wrong. I think I know what I did wrong. I was just being silly. Yes, you're all correct. Okay, all right. I knew it was me. I had to have done something stupid. Yes, I did. Yeah, Marilyn, I was just doing some really horrible maths there for a second. I don't know what I was doing. Yes, okay, so good. Simpiwe, Chad, Mary Lynn, Boycho, Amahle, Gagala. Yes, good. Well done, Trish. Who else sent me answers? Shisana, Jude. Yes, beautiful. Okay, so all of you are getting the same answers for that. So well done. That was nice and easy. Calculating the 12th term, you're all quite right. You should have ended up with 3,45 and with 3.3.2, the sum to 15, 38,44. Okay, do you need me to do those with you? I think if you're all right, it's just subbing in. Does anybody want me to do the answers on screen, or are we good to move on? We're running out of time here. We're all right. Okay, we good. Okay, all right, that's fine. Okay. So what I'd like us to focus on just in the last few minutes, because I always want to do a little bit of problem solving with you, is question 3.3. Okay, so here it tells us the second term of a convergent geometric sequence is -9, and the sequence has a sum to infinity of 12. Calculate the possible values of the common ratios of the sequence, and that's out of 6 marks. Okay, so please take screenshots. You can take a screenshot before and then a screenshot afterwards, and then you can try the question again yourself and see. Mashle, that's what I got, unless I made a mistake. Sorry, so your sum to 15. So your A value is 1,21. Your R value is 11/10 to the power of 15 minus 1 over, so like that. Okay, all right, there we go, cool. Okay, so the second term of a convergent geometric sequence is -9. How do they want you to write that? And let me give you a hint. It's not T2 equals -9. Don't write that. How can we write T2 for a geometric sequence? What do they want from us? That's it, Mosey. Well done. Okay, so they want AR equals -9. Beautiful. And the sequence has a sum to infinity of 12. So what do they want from us here? 12 equals, what does 12 equal? Sum to infinity. If you remember your sum to infinity formula is A over 1 minus R. So they want us to sub the 12 in over here. So it's equal to A over 1 minus R. Okay, so there is equation number 1. There is equation number 2. What should we do now? Remember, they want us to find the values of the common ratio. So what should we do now? Anyone got any ideas? Voloshan?
So I took the sum to infinity and I cross multiplied and I found R, A to be the subject of the formula.
Okay, all right, that's fine. Okay, so you multiplied this one out. That's not a problem. So cross multiplying, that would give you 12 minus 12R is equal to A. But because they want us to solve for R, we want to remove this A and we want to get something in terms of R. So that means that we have got to make A the subject to the formula over here. So that would be minus 9 over R. Okay, so it would be 12 minus 12R is equal to minus 9 over R. Does that make sense to everybody? Good, Voloshan, thank you. Is that making sense to everyone? And now they would expect you to multiply through by R. So we would end up with 12 minus 12R squared is equal to negative 9. Make it equal to 0, take everything over to the other side. So that gives us positive 12R squared. Sorry, I multiplied through by R. So sorry, that should have an R in it, shouldn't it? So 12R squared minus 12R minus 9. Okay, so Mbali, I divided by R on both sides in equation number 1 to make A the subject of the formula. I divided the left and the right by R. Okay, and then I'm going to take that and I'm going to go and sub it in. After you've multiplied out, like Voloshan said, I'm subbing in A over here. Okay, now I've got R as my lowest common denominator. So to get rid of that fraction, I'm going to multiply every term in the equation by R. Okay, so Trisha's giving me an answer already. Trish, you're so fast. That's really good. Well done. Okay, so 0 equals, what I'm going to do here is I'm going to divide through by 3. This is going to give me 4R squared minus 4R minus 3, just to make it a little bit easier to factorize. And now when okay, now Jude, yes, why is your first answer not applicable in this case, Jude? Can you think of why your first answer? Oh, there we go, Marilyn. You don't know. Okay. All right. You know why it's difficult, Jude? Because you don't have the question in front of you. A convergent geometric series. Hint, hint, hint. There you go, Trish. There we go, Jude. Perfect. Okay. So not your fault because the question was not on the screen anymore. So we're going to put a minus there. We're going to put a plus over here. So either R is equal to minus 1 over 2, or R is going to be equal to 3 over 2. And because this is a converging geometric series, remember there is a restriction on R. R has to be between -1 and 1. Okay, so we have to show that in the context of this question, R cannot be equal to 3 over 2. Okay, so your only solution, R is equal to minus 1 over 2. So I moved all the terms over to the right-hand side, Jamie. That's why the minus 12R squared became positive 12R squared. The 12R became negative 12R, and minus 9 remained on the right. So that's why it's still minus 9.